Hey guys, Dr. Rad here again with another heparin protocol practice problem. I had a student ask me about what if the patient's weight was 135 pounds. So we're going to take this same heparin protocol and apply it to these same questions and see what the answers will be with a patient weight of 135 pounds. So I actually did all the work already, so I could just kind of walk you through what I did there. So the first step is, with any of these heparin protocol problems, is you need to convert the patient's weight to kilograms. The most direct way to do that is divide by 2.2, and you see you get 61.3636. Is actually repeating. We're going to round that to the nearest tenth, so it's 61.4 kilograms. The paper that I previously recorded showed that the bolus strength is 80 units per kilogram, and the drip rate, the initial drip rate or flow rate, would actually be 18 units per kilogram per hour. And then in step 2 of the protocol, I'm just going to come back over to look at that. It says heparin 25,000 units in 250 ml, half normal saline, bolus dosage strength 1,000 units per milliliter. And so I just added that in here because that's pertinent information that we're going to need for solving this equation. So the first question, question A, says, what is the milliliters for the initial bolus? So we're going to take our patient's weight in kilograms, 61.4 kilograms, times the 80 units, because that's what it said the bolus was, and that'll give us 4,912 units. However, we don't want units. We want, the question said how many milliliters of bolus, and that's where we go back to our bolus dosage strength of 1,000 units per milliliter, and then that's what we have written here. So 4,912 units divided by 1,000 units times 1 milliliter, and we get 4.912, which is approximately 4.9 milliliters, round to the nearest tenth. For milliliters per hour, again, we're going to use the drip strength, we're going to use the patient's weight, and then we're also going to use what's in the bag, the heparin 25,000 units and 250 ml that we discussed earlier. So the patient's weight times the 18 units, and that gives us 1,105.2 units per hour. And then we're just going to convert that units per hour to milliliters per hour. And you can see that I arranged this just slightly differently than how I arranged it in problem A. This is more of a dimensional analysis approach where I kept the units per hour on its own numerator denominator, and then the conversion there as its own numerator denominator. A lot of times I like to do that. I like to keep everything that's here together because it's all in one bag, and it's just a nice little safety mechanism when you're doing math, so you don't get lost with where numbers go. But anyways, that comes out to 11.052, which is approximately 11.1 milliliters per hour. Now, when it calculates a new bolus, according to the paper here, it says after 6 hours, we have an APTT of 43 seconds. We look at the 43-second range there, which is step 12 in this. It tells us to rebolus with 40 units per kilogram and then increase the rate by 2 units per kilogram per hour. And so that's what we did for C1 and C2. So the new bolus, again, we're going to take the same patient weight. This time, instead of multiplying by 80 units, we're going to multiply by 40. We get 2,456 units. Again, we're going to divide by that bolus strength. So keep in mind, the bolus strength, think of it as like a separate IV, or not a separate IV, but a separate needle that contains that, and then you're just going to bolus dose that into their IV unit. Again, we multiply by 1 milliliter, we get 2.456, which is approximately 2.5 milliliters once we round to the nearest tenth. And then finally, the drip rate, because it started at 18, the directions say to add 2 units, so we're going to increase by 2. So that's 61.4 times the 20 units per kilogram hour. We get 1,228 units per hour. We multiply that again by the heparin bag, 250 ml, 25,000 units. Remember, that's connected to the IV, and that's being constantly infused. And so we just want to know what we need to reset the pump to. And we're going to reset it to 12.28 milliliters per hour, round that to 12.3 milliliters per hour. I do realize that in reality, you may not be able to have a decimal in your infusion pump, but as far as the calculations are concerned and following rounding rules, that's why we get this answer. Anyways, I hope that was helpful. If you have any other questions, if you want to try any other weights, let me know, and I'd be happy to put those together for you. All right, have a great one.